Yeah, I'm not sure. Did they get that hard in the homework? Did we get anything like that in the homework? It works with
No, the-
4 and 2. And just so we're clear, it would also work if I had maybe like a 3 and a 6 in here, right?
mhm.
Oh, come on. Drawing. Right, I would also be able to do it, but this would be, I think, z to the what? This would be the 3 power then. So z would be x cubed then. So we can do this with anything that has this sort of pattern. And if we can't factor it, we can use the quadratic. We can essentially turn it to something that looks sort of like a quadratic. So yeah, there are a lot of sort of little factoring strategies to try to get at these polynomials that are larger than x squared, right? We're probably not going to do anything larger than like quadratics in this class. Unless they look like this, or maybe if they're like factor by grouping, we might get larger, right? I think. And looking back, we got what, x equals what, plus or minus 2?
Yes, and then x equals plus or minus I, because it's
I.
an imaginary number. Yes.
And that was when this was a 4th in square, right?
Yes.
And so we're expecting 4 solutions. We get 2 here and we get 2 here.
Yeah.
But also for a minute, I think they were developing these polynomials, right? Probably alongside when they were developing the concept of imaginary numbers, right? Imaginary numbers are kind of a weird thing to talk about if you've never talked about them. When the rest of the world has no idea what you're talking about, and you just like out there screaming imaginary number, right? They don't know what you're really talking about. All right, so what problems do we need to get through? 11, 15, 17. Let f of x be quadratic. They give you the leading coefficient. They give you some zeros. So they might have their zeros written a little weird on this one. Let me throw this one back up. So the zeros might be written a little weird on this one, but they are written right there. So maybe if that confuses you, write it as a point. I guess minus 3, 0. Right, but you should be able to give me a factor from the 0, is what they're hoping. You should be able to factor it from the zeros. You should be able to put the leading coefficient on there, give me an equation. This has a leading coefficient of 1 or minus 1. So they basically want to, excuse me. They basically want to know whether or not this graph is what, a positive or negative graph. And we talked about that with the end behavior is the thing that should be giving you that. And then the other thing is, can you pick the zeros off of this graph and give me the factors? What else? Stop the annotation. Drag this down. We have that. This is graph the polynomial. And write it in completely factored form. The leading coefficient is not 1 or minus 1 on this one. So you might have to do a little bit of work to figure out what the leading coefficient is. So what I would do is write everything that you know first. You can get your zeros from this graph. So write out your zeros, write that thing out in factored form. We know it's got a leading coefficient on there. Pick another value from this graph that you can plug into your equation and try to solve that. And I think if we do those 4, get started with those 4, I think that's pretty good for now. Are there any questions before we jump into this stuff? Okay. Breakout groups is where I need to go. Hit that record. Okay. Any questions about this? So this strategy was to get the zeros out of this. So x equals minus 3 is one of my zeros. X equals 2 is the other 0. After we get our zeros, we use the the property of how your zeros relate to your factors, right? To get to these factors. So if x is k, my factor is x minus k. So x minus and minus 3 is x plus 3, x minus 2 is x minus 2. And then the only other thing we got to account for is that leading coefficient. Is there some other number out there that wasn't a factor that might be affecting this? All right, there's no questions. I'm going to call on Jerry for the next one. What are these going by? 2s. So one thing you might want to take into note is like your scaling on your x and y axis, right? They're not going by 1s on this one. So what are my factors? X equals, what are my zeros? Let's start with those.
-4.
Yeah, we get x equals a -4. We get what?
2 and 8.
2 and 8. If those are my zeros, my factors look like what?
I'm not sure mine are right, but I did x -4.
Okay, so if the 0 is x equals a -4, and we want x minus that, that should be what?
Positive.
Yeah, it should be +4. We're doing a minus and negative. And if that's x plus 4, this should be what?
X -2.
Yeah, now we're doing x minus 2 and x.
-8.
Yep. And so those are my factors from these zeros. I guess I could put x equals 2 here, right? X equals.
Why do we do like the opposite sign?
Because we want to know what is going to make this thing 0, right? And so x minus 2, it's sort of like we were working backwards from what we were previously working. When we were solving it, right, we would go to x minus 2 equals 0. We would factor these things each separately and then do the 0 product rule. And we'd have something like x minus 2 equals 0. We would typically like factor and work this way. Now we're kind of working the other way. We're starting with our 0 and we're going to the factor.
Okay.
Yep, yep. Okay.
I have a question. Will we put a 1 in front of the, that?
Yeah, I was about to ask that. So the next thing is I have to look at the leading coefficient. Is it positive or negative is basically what they want to know, right? Is this a positive graph or negative?
Positive.
Is positive. How do you know that?
Because if you draw a line, it goes up and to the right.
Yeah, so like this thing is going like that, right? The end behavior of it. It's a little dance. You got to do the dance, right? Positive, negative, positive, negative, even, odd. So this is an even function. It's got 3 factors in it, or sorry, wrong word. This is an odd function. It's got 3 factors in it. 3 is an odd number. And so it looks like a positive odd function. If it was negative, it would be going like this in the end behavior. So we're looking at the end behavior of the graph to determine that leading coefficient. But yeah, you're right. This should be positive. So if you want to put a 1 out in front of here, that's fine. If you put a positive 1, I would be fine with that too, probably. But yeah, that is basically it. F of x equals this thing, right? The other thing, I guess you can look here, is that it's going through the axis 1, 2, 3 times. So we should get 3 real solutions to this thing. We talk about what it looked like if it has imaginary solutions. I think we talked about that, right? This one is definitely larger than a degree 1, right? It has 1 real solution. What about the other solutions that are there? they'd be imaginary, right? So if you get things that like squiggle out here, like that aren't going across the axis, that's a good indicator that you're getting imaginary solutions, because we know it's increasing the degree each time this thing turns, right? So if you're getting squiggles that aren't going through the axis and stuff, good indicator you're getting some imaginary solutions in there. Here, this section, I think we're focusing specifically on mostly the real solutions, right? Who is next? Fernanda, are you getting this? Did you get 17?
I didn't get to this one.
Okay.
Um,
What are my zeros?
um, is that where it just like goes through the X, right? Or,
Yeah, so there should be what, 1, 2, 3, I think 4 of them here.
okay. So that one could be like a 0. I mean, like a -6, comma 0.
That one should be what, -8, I think.
Oh.
They're going by 2s, and so that would be 6 would be like right and 1 over right there.
And then -4, comma 0 for the next point.
So we get a -8, a -4. Should be 4 of them, I think.
And it's -4.
And then
-4.
-2. And then -4.
+4. That's it. These are my 4 factors, or sorry, 4 zeros. I want to do the factor, and so if x is equal to -8, the factor should look like what? So basically, we're flipping the sign. So if it's a -8, it should look like.
Is it positive?
Yeah, x plus 8. And so if x is a -4, my factor should look like.
+4.
Yeah, x plus 4. And then if it's -2, my factor should look like.
+2.
X plus 2. And then the last one, if x is a +4, now we're doing x
-4.
-4. Yep. So those are my 4 factors. I should probably put them all in one line, but I'm trying to squish them in here. The other thing we got to look at is this thing. And if we look at this thing, I see the end behavior, and it's coming in and going on the same side. So does it look like a positive parabola or a negative parabola with its end behavior?
With its end behavior?
Yeah. So remember, the frowning face is like a negative parabola. Happy face is a positive parabola.
That one's negative.
Does it look like a frowning face? The end behavior is like what's happening here.
Is it not negative?
It's negative. That's it. Yeah. So it's going down. It comes and goes downward, right?
Mm-hmm.
Yeah. Comes from below, goes out below. That means it's a negative leading coefficient. And that should be my function. I got my 4 factors. I got my leading coefficient. Questions about this one?
Yes, I have a question. So okay, I understand that because I got both of those right. Ooh, don't ask me that. Like for real, this driving me crazy. But for the leading coefficient, like I understand for 17 that the graph is negative. And but since the problem said that the leading coefficient will be plus or minus 1, that's how I know like it'll be a plus or minus 1. But with other problems, already give me my coefficient.
They're gonna give you your coefficient, or you might have to solve it. I think it's the next one, right?
Okay,
It's 21.
Yeah, for 21, like that's why I was getting confused. Like, I know how to point out what's my x, and know how to do the factor, like the x plus and all of that. But I didn't understand how to get my leading coefficient. So that's why I asked that question.
Yeah, we'll go through it in a second when we do that problem. So there's 21. Did anybody get through 21? No. Okay.
Yeah, I just missed that part to get the leading coefficient.
Okay. I want to give y'all maybe a little more time to get on 21. So I want to do 21 when we come back, but I want to give you a little more time with that one, I feel like. So if you want to get the leading coefficient, you have your formula pretty much set up, write everything that you know, and then plug in another point that's not a 0 is essentially how you're going to do it. You get another x value and a y value to plug in, and that should plug in every variable except for your a. Then you have to solve for a, and then you have to go plug a back in there. We'll do it in a minute when we come back. But I want to give y'all some more problems. 21, let me make sure we're not skipping anything. There's a few problems that like are on another paper. I was trying to make sure I didn't skip them. But I think 41, 43, 41's on that other paper. So what was that again? 41 shows a graph, estimate the integers. So let me share this so we're not all confused. Yeah, okay. This one. So 41 is actually on a separate sheet of paper. So I want to do 41. Oh, I'm not sharing my screen. I should have just shared second screen. That'd be better. So we should be doing, I believe, 41. So finish up 21 if you haven't done 21 already. I think most of you said you're still working on it. I want to do 41, which is on this page. I believe it's pretty similar. The graph shows polynomial, estimate the integer zeros, and state whether their multiplicities are odd or even. State the minimum degree. So it doesn't sound like they're even making you write factors on here. It sounds like they're making you write zeros and the multiplicity of the 0. And then we're going to state the minimum degree of f of x. I don't know if you noticed, like maybe, I think this is the homework that you're doing. They want something like this, right? 0 multiplicity. What's the 0? It's the multiplicity. What's the minimum degree? So it should look pretty similar to stuff that we're going to have you do in the homework. But that's 41 is the one that is on the assignment. And then 43 through 45, those look like they're all the same. They're going to give you in words, I think is what they're doing. Write a polynomial with that form. Leading coefficient, we can assume it's either 1 or -1, I think. They're assuming +1, okay. And then they give you a few properties. They want a degree 3 with the zeros, and they tell you the multiplicity of the zeros. And so we're getting into multiplicities after 21 is what it looks like. Questions about these? So 41 and then 43, are they all signed? What are they signed? 43, 45, and 47. Yeah, those are all signed. Okay. 43, 45. Oh, 44 is not assigned. It's extra on there. Okay. We'll do 43 and 45. If you do those two, you could probably do the 44. I want to work on 21 and then those 3 new ones. Any questions before we jump back to groups? All right, try it out. Try something on your own. Whoop. I wanted to pause. Don't tell me. Start that recording again. Okay. So fill out the information you know. If you fill out the information you know, there's one extra little step to finding that a. You basically have to pick another point that's not one of your zeros and plug it in. So my y was 1, my x was 0. I plugged in that information. I solved for my a. I know my a is 1/2. And so now that I know my a is 1/2, I can go throw that back into my equation. I can get this thing. So the final thing you have should be f of x equals 1/2, x plus 1, x minus 1, and x minus 2. Questions about this? Was that 21?
No, 41.
All right, I'm gonna throw this up here. I'm gonna just swap. It's gonna take me equally as long. Either way, I think. Sharing, yes, I want to share. This untitled thing. 41 was the next one.
Yes.
Why are you flopping screens on me then? All right. All right, who is next on my list? Kathleen.
I didn't get this far. I was doing 21 the whole time.
Okay. So the graph polynomial is shown here. Estimate the integer zeros. So can you give me the zeros off of this thing?
-2 and then +4.
It looks like a -2. It looks like a +4. So if you can do that, you can do at least half of it there.
Okay.
The other half is talking about what, multiplicities?
Mm-hmm.
So if we look here at this -2, what sort of multiplicities does this look like?
Negative.
So when we talk about multiplicities, do I got a Desmos graph? Stop that annotation. This was like the thing that we were talking about earlier. Is this sharing? It's not sharing the right thing, is it? If I just share my screen too, it would share. Okay. So this is the sort of thing that we were talking about kind of earlier. Does it look like maybe one of those things? Or does it maybe look like one of those things? If it goes straight through, right, we can assume that it's probably one. But the second we start getting curves, so if it curves and bounces, then it would be an even power. But if it curves and does something like that, then it is an odd power.
Okay, so it's odd.
And so we're looking back at this thing. This thing looks like it's an odd. And I just deleted all the stuff I had written before. Didn't I? Yeah, okay. Yeah, I'd erased it. So x equals -2 was one of the zeros. The multiplicity, ooh, what do they say? I'm not sure what they. I would say it's probably at least 3 with the way it curves through that line. Graph of line, estimate the integer zeros, state whether their multiplicities are even. Multiplicity is even or odd. So I would say it's probably at least a multiplicity of 3, but we know it's odd. It could be 3, 5, 7. The other one was what? X equals 4. Is that an even or odd multiplicity? So now we're looking at.
Is it even?
Yeah, it's even because it hits it and it bounces back, right?
Mm-hmm.
It's like you're walking into a party, you see someone you don't like, and you're like, nope, not having it. You're getting even with them. You want to go to the party and you just like wiggle your way in. It's kind of an odd thing to do. Okay. We get even. So this is probably at least a degree 2, right? It could be more, could be 2, 4, 6, 8. But I'm thinking it's probably at least a degree 2 to graph polynomial students. Estimate the integer zeros. Here's my zeros. Make sure I'm answering everything that they asked. Whether multiplicity are odd or even, state the minimum degree. So what's the smallest degree that this thing could possibly be? If we have 3 zeros here and we have at least 2 zeros here,
It would be 2. Or would it be 3?
so there's at least three of those things, right?
Mm-hmm.
And there's at least probably 2 of them here. 3 and 2 should be how many zeros at least?
Oh, at least 5.
At least 5, I think. So this should probably be at least a degree 5. We could also go over turning points, but I think that might be deceptive because we have 2 turning points. And then we also have like this thing.
Mm-hmm.
I think the 5 is probably the better solution.
Okay.
We can also do turning points plus 1. This looks like a cubic. It's wise. Do you know which one they're going to go by on this one? That one's kind of
Which one
confusing.
They're gonna go by for what?
Because usually you do the turning points plus 1, right? But since this is look like one of those cubic sort of things, it looks like maybe we don't get a whole turning point out of it.
So it's an inflection point, not a turning point?
Yeah.
If it's an inflection point, then it's not a turning point.
Yeah, but they're asking for the minimum degree of the function.
But an inflection wouldn't add to the degree, would it? I don't think so.
Well, you would have at least 3 zeros here and you'd have at least 2 zeros here, right?
Yeah.
And so you'd have at least 5 zeros, so that would make it at least a degree 5.
Yeah. I mean, that's what I usually do. I usually go by the zeros more than the turning points because the
Yeah.
turning point can be deceiving
Yeah, okay.
when you have an
Excuse
inflection
me.
point.
But excuse me here, we have how many points? We have 1 point in the minus, oh no, where is it? 1 point in the 4, another points here. We have 3 points. But when we consider the other points where it's not balanced,
Here,
like it's
so-
across the -2, it's like 1 point, 1, 2, 3. We have 4 points and the half, it's like it's going to be 4 degrees. It's not 5 degrees.
So if we look at the x equals -2 point, right?
Yes, this one is 1 point. We consider it
It's
as
one-
1 point.
It goes through at 1 point, but what's the multiplicity for that?
It's an odd because it's an odd.
It's odd, and so if it's an odd multiplicity and it doesn't look like it goes straight through, right? If it went straight
It's
through,
yeah.
you could probably say it's a multiplicity of 1, but since it does the little cubic thing where it kind of like saddles there for a second and looks like it looks like it goes straight, but it never really goes straight. It's always just like kind of increasing.
In this case, how we can define this point?
So that's an odd multiplicity, and it should be at least 3 because it does the little curvy thing.
Because this one, it confused me. Okay, we consider it as 1 point because it's an odd. Okay, it's not balanced as an even function. It's like it's going up. Then
Yeah, it doesn't go straight through it. It kind of levels out like right around there. And so that indicates that it's at least 3, right? A multiplicity of 3. It could be more. It could be 5. It could be 7, but it's at least 3.
okay, then 3, 4, 5.
And the other one at x equals 4, that's an even, right? And so the smallest even number we can have is 2.
Yes, on the even, yeah.
And so since we have something that's at least a multiplicity of 3 and at least a multiplicity of 2, when we add those things together, these
It's
have to
going to
be,
be 5.
yeah, at least a multiplicity of 5.
How about the other point? Where is it? 1, 2, 2, 2, 3. The point is when x equals to 2 and y equals to 3. This one too is a point.
If we do 1, 2, 1, 2,
The other one
Maybe like right
between the
here?
odd and the even function.
I'm not sure. Because 2, 3 is like on the graph, like, right? But like, I'm not sure that has anything to do with the zeros. We're looking at where it goes through the axis.
Okay, you mean here when it's just to look where for the x-axis for the zeros? We don't
Oh,
change-
are you talking about the turnaround at 2, 3?
Yes.
Oh yeah, so I would look at the zeros. That's what we're talking about. The zeros are a better indicator of what degree of the function is than what the turn points are. Because like with this thing, with the cubic looking thing, right? We can have more zeros here, but
Mhm.
our turns aren't going to capture that. So it's better to look at your zeros when we would determine the degree of the function.
Good. Thank you.
It took me a second. It's been my brain's still waking up a little bit.
When it's odd, is it always going to be 3? And when it's even, is it always going to be 2?
It's at least that. It could be more. Right? It could be 5, it could be 7. So these are also valid things. It could be a higher degree function, right? If this is 5, then we have at least a degree, what, 7 function or something? 2, 4, 6, 8, right? So it could be more. These are possibilities. 5, 7. And like this is going back to like the sort of Desmos thing, right? If I have more, how does it change the shape of my graph? So basically between like an x2, let me get these annotations out of here. Let me clear them so they're not in the way. If I have an x squared, how does that differ from the way that like an x to the 4th or an x to the 6th looks? Ooh, that's not the right place. If I go 4th, right? If I go square versus 4th versus 6th versus 8, they all look very, very similar. Except when we go higher, they just look more curvy. But they all sort of have that parabolic shape when we go to higher order stuff. For just doing single factor right there, right?
What if it points downwards? Is it still even? Like,
If it points downwards, that means you
yeah.
got a negative leading coefficient. So that's your leading coefficient that's giving you that upwards or downwards.
Oh,
Yeah,
okay.
it's still going to look like the same picture, but like flipped with a negative leading coefficient, basically. Same thing if we have a cubic versus a 5th versus a 7th. They all have that little squiggle saddle point thing happening in there, right?
Yeah.
So we don't know. It could be 3, it could be 5, it could be 7. We don't really know unless we check other points. And I think they're trying to keep things maybe simpler and just you want to give them the minimum degree, right? And so that's why they ask for the minimum because it could potentially be higher, but we're just going to assume what the smallest thing would be, right?
Yeah.
Okay, so that was what? 41 was this one? 42. So maybe I could point out this one would be what? An even multiplicity. This one would be what? An odd multiplicity. This one would be an odd multiplicity. What are they do going by? 2s. So I think we'll get one at -8 that is what? Even. So I know this one isn't one that they made us do, but I'll do it right quick. Just to kind of drill home the point, I think that's at a -4. And the other one is at what? 2. So we get a -8, we get a -4, and a 2 are our zeros. This one is even because it hits and bounce. This one's got a little saddle point. We're going to call it odd. This one's got a little saddle point. We're going to call it odd. And so 2 + 3 + 3, 6, 7, 8. I think that's still it. So that would probably be a minimum degree of 8 to get that thing. Questions about this? I know I went through that one pretty quick.
It helped. That one did help. 42 helped.
Okay. Yeah, you have something very similar in your notes or in your homework that you're going to have to do, the stuff that's graded. Okay. Any questions before we go on to the next few?
I have a question. So to kind of sum it up, to get our degree, like for 42. So how it was like even, odd, and odd, and how we had to add those together. That's how we could get our degree.
Because we're assuming the smallest even is going to be 2, and the smallest these odd things are going to be is 3.
Okay, I was just trying to confirm.
Now, if it went straight through, right? These are saddling. So if it went straight through, so if we had something that looked like, oh man, can I even draw it right quick? If we had something that just went straight through, we would assume that's probably 1. If it bounces, that's at least 2. But when it saddles and does that weird saddling thing, right? That's when we assume it's got to be at least 3. It's an odd multiplicity. There are multiple ones, right? Is what we're saying when we say odd multiplicity. And if there's multiple ones and it's an odd, the smallest multiple odd is 3.
Okay, gotcha.
So this would be 3, 4, 5, 6. So this would be at least a 6-degree function. Because we got 3 here, we got 2 here, we got 1 here. Okay. And 43, who's next? Vanessa, did you get 43?
I didn't get to that one yet.
All right, so what are they saying? Write a polynomial in factored form that satisfies the conditions. Let the leading coefficient be 1. So if we look at our zeros, we see as zeros is 1 and 6 is what it looks like. So if I know my 0 is an x equals a -1, how does my factor for that thing look?
X plus 1.
So that would be x plus 1. And what about this other one, Vanessa?
Be x plus 6.
So you want to do the opposite sign. So what would the opposite sign make this?
-6.
Yeah, it should be x minus 6. So we have this much. The other thing is multiplicity. So if this is a degree 3, if -1 has a multiplicity of 2, what power should I put up here?
Would be a power of 2.
Yeah, so I'm putting a power 2. This 0 is happening twice. This 0 has a multiplicity of 1.
To be power 1.
Yeah, you could put a 1 up there if you want. If I'm being honest, most of the time I write this, I'm probably not going to put that 1 up there. Probably just going to leave it off and just say x minus 6. And then the other thing is the leading coefficient is 1. So they give that to us in the problem itself. So if you want to put a 1 out here, that's fine. If you don't want to put a 1 out there, I'm probably not going to put a 1 out there. But the leading coefficient is 1. And I want to write my function out. This is my f of x function. And they said this is a degree 3. So we should end up getting a cubic. Are we going to get a cubic when we multiply these things all together? I know you don't have to do distribution, but you've done distribution enough, right? The first 2 things will multiply as x times x if we actually separate this out and do it the correct way. We have 2x plus 1s here, right? First thing I would do is multiply those 2 things together. I would get an x squared. The next thing I would be multiplying by this, I'd be multiplying an x squared by an x. You should end up getting 3 or x cubed, right? So they ask for a degree 3. The other thing you want to do is count your degrees, right? 2 and 1, make sure they add up to 3. Any questions about this one?
I have a question. So I could leave it as like f of x equals, x plus 1 the square root, and then x minus 6, 1. I wouldn't have to simplify the x plus 1 out, like the x plus 1 squared out.
No, I was just expanding this so that people could maybe see that when we multiply like these 3 leading terms, right, we're going to get an x cubed out of this thing.
Okay, because
yeah, this is what I would expect probably for your solution, this thing right here, right?
Okay, because I end up thought we had to simplify that out. So
Expand
but
it?
yeah, I thought we had
Or-
to, break the x plus 1 squared. I thought we had to break that out.
No, because we actually want the factored form, right? And if we start going in this direction, we're going the opposite of factoring. This would be expanding. Yeah, so you want it in the fully factored form. See, I can see that there's 2 zeros here. I can come back and like, if I look at this formula, I want you to be able to see that it's got a multiplicity of 2 at the 0 of x minus 1, right? It's got a multiplicity of 1 at the x equals 6. Any other questions on this one? So if they give you the zeros and they give you the multiplicity of the zeros, I'm hoping you're able to take those things, put them together, and give me a function, a polynomial function in factored form. If we expand this, right, we can expand it. It's going to give me a cubic polynomial. It's a possibility they might ask for it in expanded form, right? But they don't really say here, right? They just say, give me a polynomial and complete factored form. There it is. And so they actually ask for it specifically in this form. Okay, who's next? Brian, are you around?
Yes, I'm still here.
All right. Are you getting these? We have a 0.
Yeah.
We got a 0 of 2 and we have a 0 of 6. Is what it looks like for this one. So what would my factors look like?
First one would be x minus 2.
X minus 2, and then the next one is x minus
6.
Yeah, that's it. And if 0 has a multiplicity of 3, what number am I putting on here?
You'd put a square of the 3. Or sorry, no, you'd oh goodness, I've forgotten the word. Yep, that's exactly what I was trying to. Exponent, thank you.
You'd cube this thing, and then
Cube, that's what it was.
This thing would be what? Power 1.
Yes.
Is this what they asked for? Is that a degree 4?
You have to put the f of x, I believe, right?
Yeah, that's it.
Okay.
But yeah, this should be a degree 4, right? We get 3 plus 1. Should give us a degree 4 polynomial if we multiply it all out. We should get x to the 4th as our leading term. Questions about these? 5:47. Which one's more do we got to do? It's like 10 minutes. Okay. Stop annotations. 47, 49, and 51. So 47, 49, 51. I want to give you all like, I don't know, 5 minutes or so to do these. Graph is either cubic, quartic, or quintic. So it's either 3, 4, or 5 is what it sounds like they're saying. In English, cubic, quartic, or quintic means what? 3, 4, 5. That's the degree of the polynomial. They want this in complete factored form. And in 51 and 52, the leading coefficient is not plus or minus 1. Two. All right, so what should I ask it? What degree are these things? So 47, what degree would this have? It's got at least 2 zeros.
Would it be 3?
I would say this is probably a 3rd degree, right? Also, I know what 3rd degree functions look like. That also helps. If you have like x to the 3rd, right? And so if you have x to the 3rd, this thing looks like saddling points. But when you start adding, and I think I did this in the notes, right? When we start adding things like x squared, or we start subtracting like other things from it, that's where it gives us the more squigglies. Same thing with like my x to the 4th, right? My x to the 4th just looks like that parabola. But when I start adding things like x to the 3rd to it, let's do maybe 2 of them, it starts adding squigglies to it basically. So when I start adding my smaller degree variables, that's where the squiggles come in. Extremely technical math term called the squiggles. Oh, I'll leave that. I need to come back to here. Yeah, that's it. And where's my annotations? So this one is at least a degree 3, looks like. What about this one? So it's either
Would it be 3 as well, cubic?
so it's either 3, 4, or 5, right? If we look at this, what sort of thing does this look like? Does this look like an odd function? An odd degree function?
Yes.
Ooh, this looks like an odd degree function. This looks like a,
Negative.
yeah, it looks like a parabola, right? With its end behavior. It looks like a negative parabola.
The
Since we
49th,
know,
right?
huh?
It's the 49th, right?
49, yeah. I was going through here and asking about the degree.
Okay.
And so that's gotta be a 4th degree because it's the only even number they give us.
Yes, it's 4th.
And we know this has to be an even degree function because the end behavior looks like a parabola. It comes in and goes out on the same side, basically, right? What about this one? What degree is this guy
Is
got?
odd.
It is odd.
5.
This gives me what, 2 and 3, I think.
No, 1, 3, yes, 3,
So this has to be the degree.
5.
Yeah, if you tell me 3, you're not gonna have enough, right?
Yeah.
So that one's got to be a degree 5. Okay. All right, so I want y'all to try this on your own. I know I'm giving you a little bit of dead space in here. But I'm hoping you're writing out the factors. I think there's 2 factors on this first one. I think there's 2 factors on this one. So write out the factors and then figure out their multiplicities. Next. Number is that? 2, 4, I think is what I'm getting. Josh, did you get this one, 47?
I'm working on it right now. I'm having trouble finding A.
I thought they were just doing ones, except for 51.
Oh yeah, you're right. It does say coefficient. Oh no, it
So-
says it's not plus or minus 1, so we still have to find A, right?
For 51 and 52 is what it looks like. I could be wrong. I'll double check. But what are my two factors here?
That's going to be x plus 2 and x minus 4.
X plus 2 because it's a minus 2 is a 0. And x minus 4 because positive 4 was our 0. And so the first one, what multiplicity does this thing have? The x plus 2 has a multiplicity of 2, and this one has a multiplicity of
1.
yeah, just 1. And so that gives me a multiplicity of 3. What's another point? Minus 4. Maybe minus 430. It's hard to see. It's hard to see where it goes through evenly at a good point. Probably going to be a little more accurate if I give you something, but it looks like maybe we throw in what 30 and a minus 4. My eraser. I didn't mean to write that marked. Okay. And so if we throw in what 30, if we do like a minus 4 plus 2 squared and a minus 4 minus 4 minus 4 plus 2 is going to give me a minus 2. I'm going to square it. That's going to give me 4 times, ooh, it should be minus 30. That's it. Sorry. Minus 30 minus 4. Give me minus 8. I think it's supposed to be 1. It's really close to 1. So I think these ones they're assuming they're 1 because this is going to be minus 30. This is going to be 30 over 32 or something like that. So I'm pretty sure for these two, they're assuming they're 1 is what it looks like. It looks like the last one, we can't assume that. But for these, I would assume it's 1. And so since we're assuming for these two, it's 1, what number should I get there? Is it positive 1 or negative 1?
Should be positive 1.
Yeah, it should be positive 1.
Positive in the graph.
And this one, I'm getting what? Minus 3. So this thing should be x plus 3. And I'm getting at the end. I'm going to speed things along a little bit here. And what power on these should I put? 49. These should both have what number?
2.
2. And so if I do 2 and 2, that should give me the 4 for my power of 4. And the leading coefficient on here should be what?
Negative.
It should be
It's
negative.
so
So we're going to throw a negative 1 on here. This is the one they wanted us to do some figuring on. So I think we have x plus 1 is one of our factors and x minus 1 is one of our factors. I believe it's happening twice here and happening 3 times here. So the other thing we got to do is pick a number and solve for it. So I think I'm going to pick this number, which is 0 minus 2. And if I do that, I plug in what minus 2. Ooh, I forgot my a here. And I get an a, and I get 0 plus 1 squared. That's going to give me a 1. And I get 0 minus 1, and I cube it. That's going to give me a minus 1. So what I end up getting, I think, is a is a positive 2 is going to be my final solution here. So I believe I'm getting a 2 in this thing for my a. If y'all got questions about these, I'm here for it, but that is the end of the class, right? It's 1:40 now.
So tomorrow is the review. So there's no lecture notes due for tomorrow, but if y'all want to get started on the review, feel free because we probably won't finish it all during class. So you can always come with questions as well.
I would go back and look at the picture stuff with the borders. A lot of people are adding when they're supposed to be subtracting. So be
Yeah,
careful with
I
that.
noticed that as well.
If they give
I
you the
think-
inner dimensions, you have to add the border, right? If they give you the outer dimensions, you have to subtract the border. So I think there was an issue with that.
I think the border one was on 2 homeworks because I graded one as well. So y'all got to go back and check those and make sure you understand how to do those border ones. The ones where you have to draw it with like a sidewalk around it or whatever.
Yeah, it could be a sidewalk around a pool. It could be a picture frame around a picture. It's uniform. They're all the same problem, basically.
Is there somewhere else that I could find some like examples of these?
I'm sure we could Google some, or there might be some in the book. Is there more in the book?
I have the book itself. I'm gonna have the digital copy too, but that's why I was asking the other day. You know how I was like, I don't understand how to go through the book and stuff. Cause like when I was trying to pull up the answers and stuff, I could just check over my work. I don't know. I felt like I kept just going to the wrong thing. If that makes sense.
These are from Rockswold.
Yeah, I have the book. I have like the digital one, but I have like the hard book as well.
And they should be in the back, right? These solutions to the odd number.
Yeah, you can look up more in the book and see more practice. I have to get going today.
All right.
Bye. See you tomorrow.
Okay, thanks everyone.
Okay, and so if we go Rockswold.